The zoom is going to have this stuff. It's too fast. It's too tricky.
Good morning. Guys, we're the Lords of Light and Magic. My name is Ricardo Fuentes. This is Kevin Richard, Dylan Jackson, Dani Ismail, and Andrew Yang. We are more than glad to finally be presenting to you guys the semi-completed, I'll explain that in a bit, railgun. This is pretty much a museum piece right now. So it's semi-functional. Just how a lot of aircraft that you see in museums nowadays don't have the control circuitry, so that some wacko can't jump in and turn it on and shoot the place up. It's semi-functional in that it has pneumatic functionality. We'll be explaining that later. And, but all the electromagnetic components, it's an electromagnetic device, by the way, are not functional. They're not hooked up. The control circuitry is not there. So you guys have to worry about it. Well, the device itself consists of five main modules: the accelerator, power bank, the UI, and the injection system. Now, railguns have been around for a long time, for over 30 years. They were initially conceived. They were the holy grail of electromagnetic weapons for hobbyists and government organizations alike. They've been explored to exhaustion by the government. They built huge ones, hobbyists have built tiny ones, to varying degrees of success. Overall, they've been deemed kind of impractical weapons. Efficient, but impractical weapons, at least for use as weapons. Now, the basic governing principle behind the railgun, or any railgun, it is an electromagnetic device, and the basic governing principle is the Lorentz force. The Lorentz force is something you cover in any Physics 2 class, any INM class. It simply states that, well, you see it up here in this nice diagram. Those two rails, we've got a railgun, and the current circulating through those rails, completed by a projectile or an armature, that bar. There we go. All right. So this armature right here completes the circuit between these two rails. That causes current to flow and complete the circuit, and that induces a magnetic field around these rails. That magnetic field, combined with the driving current, makes for force in the forward direction. That's pretty much what the governing principle, though there are a lot of details that will make the railgun more efficient, less efficient, not work. No matter how many details there are, it's always stays the same governing principle behind railgun operation. Now, I'm going to go ahead and pass it off to my teammates that will explain the 4 individual modules.
My primary role in the development of our railgun was the user interface module. At the heart of the user interface is, as you might expect, the button that fires the railgun. However, as Ricardo began to allude to, the name railgun is a bit misleading. This is far from a gun in the conventional sense, and as such, the user interface and the means by which this system is operated differ significantly from conventional and more pragmatic weapons, such as a rifle, for instance. The prime directive, if you will, of our group has been the safety of the user and of anyone else who may be present during the standard workings of this railgun. And it simply could not suffice to just have one button that could be accidentally pressed and perhaps cause property damage or loss of life. Therefore, our user interface employs several safety features to ensure that only the most strictly controlled firings can take place. I'll hold up the user interface here. The first most basic safety feature is that it's. I assure you, none of you are. As Ricardo said, this is a museum piece. There is no way that it can be fired. I didn't hear most of that. Perhaps I shouldn't. So the first most rudimentary safety. I'm sorry. Maybe later. The most rudimentary safety feature of the railgun is that the user interface is connected by a 30-foot long cable, such that the user, when operating it, doesn't have to be standing right by in the event that, God forbid, something should happen to one of the capacitors. It can be safely operated in a separate room. Before it can actually be fired, what first has to happen is 3 safety switches have to be set in sequential order, first, second, third. We assume that these can correspond, say, to like no one in the line of fire, everyone is wearing protective equipment, etc. We can actually specify this. There is also the 2 locks you see here correspond to key charging the capacitors and arming the rails themselves. As Ricardo said, to actually turn the key that would charge the capacitors at this point would do nothing because the capacitor bank is not intended to be functional yet, although we anticipate that it certainly could be. The arming switch, however, is in a way the final safety switch. Nothing can happen until that's pressed. Once these 3 have been sequentially set and the arming switch has been turned, the weapon can be fired. However, this blue button here serves as the emergency reset, which at any point during that process can be pressed to initiate a hardware reset of this system. And then nothing could happen until this has been returned to the off position. And these have been switched off. So the code that is written to the microprocessor inside there proceeds in the following manner. When the system is first powered on, we don't assume that the switch value is already in our proper place, and therefore nothing will happen until all the switches have been turned off. These binary numbers you see here correspond to right and left. To the states of the 3 safety switches and the arming switch, respectively. That is, the rightmost number is the first safety switch. The second from the right safety switch is the second safety switch. The third is the third, and the first one here is on. 0 corresponds to off, and of course 1 corresponds to on. So only when they've all been switched off is the system considered ready. If at this point, as with any other point, the reset button is pressed, return here and begin the process over again. Once the first safety switch and only the first safety switch has been triggered, because the system is interpreted as being at the first safety level. If any other input after that point is given, as is the case at any of these levels, this will go back to reset. So as I said, they have to be toggled in a sequential manner, first, second, third, and only when those 3 have been toggled and the key has been turned if the system is considered armed and ready to fire. So next, Dylan, who will discuss the power level.
Okay, so the important thing in capacitor bank is in a railgun is to have a high current flow through the rails, creating a strong magnetic field, which in turn provides a strong lorentz force. In order to do this, you want to have a strong, a large amount of energy used in short amount of time. One of the best ways to do this is the capacitor bank. So our capacitor bank consists of 21 aluminum electrolytic capacitors, which were kindly donated by Cornell Jr. They are each rated for 10,000 microfarads up to a DC bias of 450 volts. I've arranged them in